The Hubble Space Telescope has been orbiting Earth for over 34 years, and during that time, it has achieved remarkable success. Although it was not originally intended to study bodies within our solar system, it has done so consistently, capturing awe-inspiring moments that might have otherwise gone unseen. Since not every planet or object in our solar system has had a dedicated space mission, Hubble has become an essential tool in uncovering many hidden aspects of our cosmic neighborhood. Now let's embark on a journey through the solar system, moving outward from Earth and exploring a range of fascinating celestial objects as seen through Hubble's powerful lens. Our voyage begins with the Moon, Earth's closest neighbor. Because the Moon appears quite large in the sky from Hubble's vantage point, the telescope cannot capture its entire surface in a single image. Additionally, other missions like NASA's Lunar Reconnaissance Orbiter provide more detailed imagery of the Moon, so Hubble's time is usually better spent elsewhere. However, in 2012, Hubble did turn its attention to the Moon during a special event, the transit of Venus across the Sun. Scientists used the Moon as a reflective surface to detect subtle changes in sunlight caused by Venus's atmosphere. These changes revealed information about the composition of Venus's atmosphere. Although this composition was already known, the experiment served as a test of the technique, which is often used to study atmospheres of planets orbiting distant stars. Since Hubble cannot directly observe the Sun due to its brightness, using the Moon as a giant mirror allowed researchers to gather valuable data. Unlike the Moon, Mars is well suited for Hubble's observations. The telescope can view the entire Martian disk, something orbiters near the planet often cannot do. These observations have proven invaluable for monitoring global dust storms, seasonal transitions, and various weather systems. Such data help scientists plan rover missions and predict future weather patterns on the Red Planet. In one notable time-lapse, Hubble recorded a massive dust storm blanketing the entire planet, obscuring surface details. Mars's small moons, Phobos and Deimos, can be seen zipping around in the background. In another time-lapse, Hubble focused on Phobos, capturing its movement over just 22 minutes. Phobos is particularly intriguing as it completes an orbit around Mars in only 7.5 hours, making it the only moon in the solar system that orbits faster than its planet rotates. As we journey beyond Mars, we arrive at the asteroid belt, a region teeming with diverse and dynamic objects. One such object is Asteroid 6478 Gault, which drew attention in 2019. Despite its comet-like appearance with twin tails, it is, in fact, an asteroid. The presence of tails is thought to be the result of the Yorp effect, a phenomenon where solar radiation gradually increases the spin rate of irregularly shaped bodies. Gault, about 3.5 kilometers in diameter, spins once every 2 hours, nearing the rotational speed limit that such an object can endure. This rapid spinning causes surface material to be flung into space, forming the visible tails. Gault, like many similar asteroids, is a loose conglomerate of rocks held together by weak gravity and may eventually break apart completely. Another captivating object in the asteroid belt is P2010A2. At first glance, it looks like a typical comet, but a closer look tells a different story. What appears to be a comet's nucleus is actually the aftermath of a rare collision between two asteroids. The X-shaped pattern near the center is composed of debris from the impact. Some of this material is slowly falling back due to the weak gravitational pull, while the rest escapes, forming a tail. Despite such chaotic events, most asteroids follow relatively stable, circular orbits. However, when one strays too far, similar to the behavior of comets, it risks encountering the immense gravitational pull of Jupiter. Jupiter, often referred to as the solar system's vacuum cleaner, dominates this region with its powerful gravity. It holds nearly 75% of all the mass in the solar system outside the Sun. One of the most dramatic demonstrations of this power came in 1994, with the impact of comet Shoemaker-Levy 9. After being captured by Jupiter's gravity decades earlier, the comet was eventually torn apart into fragments and pulled into a fatal trajectory. When these pieces finally slammed into Jupiter, at speeds of about 60 kilometers per second, the results were unprecedented. Fireballs erupted, reaching temperatures of over 23,000 degrees Celsius and rising thousands of kilometers above the planet's cloud tops. The largest impact left a dark scar about 12,000 kilometers across, roughly the size of Earth, and unleashed energy equivalent to 6 million megatons of TNT, hundreds of times more powerful than the world's combined nuclear arsenal. Beyond its gravitational might, Jupiter also showcases stunning auroras. While Earth's auroras are visible to the naked eye, Jupiter's are far brighter in ultraviolet light. Thanks to Hubble's ultraviolet capabilities, scientists have been able to study these glowing displays in detail. During the Juno spacecraft's mission in 2016, Hubble monitored Jupiter's auroras daily for months. The observations revealed that Jupiter's auroras shine with a power of about 100 terawatts and, unlike Earth's, are constant. This persistence indicates that they are not solely caused by solar wind. Instead, data suggest that charged particles from Jupiter's own radiation belts contribute to the effect, funneled into the atmosphere along magnetic field lines. Alternating electrical currents within the magnetic field, rather than direct currents, appear to power these radiant phenomena. Moving from Jupiter to one of its most intriguing moons, Europa offers the possibility of alien life closer to Earth than anywhere else. Europa is an icy world, but beneath its frozen shell lies a vast ocean of liquid water. This hidden sea stays warm due to tidal flexing, a process in which Jupiter's gravity stretches and compresses the moon, generating internal heat. While spacecraft like Voyager and Galileo provided detailed surface imagery during their flybys, Hubble's strength lies in ultraviolet observations. It has detected what appear to be water vapor plumes erupting from Europa's surface, strong evidence for a subsurface ocean. These plumes likely carry material from the ocean to the surface, including sodium chloride, common salt, which Hubble identified in visible light. Galileo, using infrared sensors, missed this because salt's key spectral features don't appear strongly in that range. The presence of sea salt suggests that hydrothermal activity might occur at the ocean floor, much like on Earth, where such environments support rich ecosystems, while sending a submarine to Europa may still be decades away. These discoveries point to the Moon as a prime candidate in the search for life. Next, we turn our gaze toward Saturn. Since the end of the Cassini mission in 2017, Hubble has become our main window into this majestic gas giant. Hubble regularly monitors Saturn's atmosphere, capturing vast storms and seasonal shifts. Cassini only observed Saturn for half of one Saturnian year, so Hubble's ongoing observations are vital to fill in the gaps and continue the timeline of data. Alongside its scientific work, Hubble has also captured stunning views of Saturn's rings and moons, revealing the planet's breathtaking beauty. As our exploration continues, we reach Uranus, the first of the ice giants. Like Jupiter and Neptune, Uranus has visible atmospheric storms and auroras, though its magnetic field is notably misaligned with its rotational axis. The planet's tilt is so extreme that it appears to roll along its orbital path, leading to highly unusual seasonal variations. One notable event observed by Hubble occurred in 2006, when the shadow of one of Uranus's moons crossed the planet's face. This was the first time such an eclipse had been seen since 1965, when telescopes lacked the ability to capture such distant phenomena. Since then, Hubble has continued tracking Uranus's atmospheric changes. When one of its poles points toward the Sun, a bright polar cap forms, which fades as the planet nears its equinox. With only 34 years of observation so far, Hubble has yet to witness even half of Uranus's 84-year orbit, leaving much still to learn. And so, through the powerful lens of Hubble, we've traveled from our moon to the icy edges of the outer planets, uncovering a universe of activity and mystery right here in our own solar system. Each discovery, each image, is a reminder of how much more there is to learn, and how tools like Hubble continue to reveal the hidden wonders of the cosmos.